Good evening. This is Bowie Zhao here with ECE4574, Round 2, Team 2, here to showcase our internal pathfinding algorithm. So our team was tasked with refining the pathfinding API definition and implementation, as well as being the intermediate between the other teams, meaning we had to have a standardized format for what we'd agreed that we would send to each other. What you see on the right in our JSON script is an example of what we agreed to send, with a robot array such that it can support multiple robots with an ID vector, currently only implemented as one for testing purposes, and every previously absolute x and y coordinate now changed to latitude and longitude. So this is our start vector, and our end vector is here with the boundary box size defined here, and any obstacles in between as an array with height vectors for each and every single one of them. Our main programs that we will be running on the server are pathfinder.py, seen here, and lat-long conversion, which is a submodule that is called by Pathfinder. The main high-level function that we call inside here is pathfind from JSON, and that is what we will be leveraging. So what this does is it inputs this file and runs it in my pathfinding program that is custom written seen right here. This is a unit test program that calls 6 test files, test 0 to test 5, with different forms of inputs and different types of computation for each, such that it performs an output and it checks it against the original pathfinding. Test 0, seen here, is a very small map with no obstacles. This is done to showcase that our unit test can also run even if it does not have the key item of obstacles, which it does detect correctly. Item 1 is a medium map of light computation distance. Test 2 is a large map of medium computation. Test 3 is a large map of high computation. Test 4 is a error condition, which is done intentionally to make sure that our unit test program and regular program detects it correctly. And test 5, seen here, is one of the highest computation programs we can run. This inputs it into our pathfind from JSON file, and what it does is it basically checks the original file that it sent in once with a weight vector. So it basically runs it twice. The first time acting as if it was the real program, and the second time as a unit test, where it basically goes through and matches the weights for the path cost each and every time, matching the values such that it knows that they are correct all the more. So in essence, it almost runs it 3 times to test the correctness of it and for error checking as well. One thing that we did for latitude and longitude conversion is using this function down here, which will be run later to show that we are converting our latitude and longitude values to an intermediate absolute value such that the A-star pathfinding algorithm can use it to detect the shortest distance. So I shall now run the test file. The test file is test P5, so run. This is the first file. This is the second one, third, fourth, the fifth one. The fourth one is obviously the error file that I noticed before, but since it tested correctly that it was invalid, it passed the test. And the last test is the most computationally intensive. So thus our unit test has passed all 5 or 6 of our tests. One example that I do wish to show is the pathout.json. This is one example of what it is exactly that we will be sending from that we are outputting from Pathfinder, which is seen right here as pathdict. And this is the format that we have agreed upon between the teams to send from the output of our pathfinding API, which are the coordinates, which steps it through the exact steps it takes to get to the end location from the start latitude and longitude all the way to the end latitude and longitude, and the computed path cost, which, as you can see, 298 matches what we found in the last program. And this file is just a demonstration of what this is. We have also added the absolute x and y value in case it might be used later, but it is not required. Lastly, I'd like to showcase a testing file that we use to make sure that the latitude and longitude were tested correctly. This can be seen right here. So this file is a Python unit test program, which essentially asserts and gives our conversion programs a value and makes sure it runs it correctly. And this is our main function it is testing. So I can test that just now. Python lat long test. And as you can see, it ran both of these tests and made sure that the value that it put in and what it got back was asserted correctly and that they are equivalent, which showcases that our scale and value conversion are being done correctly. So this overall concludes the demonstration of Team 2's internal unit test program. Thank you very much.